Hello everyone, this is Dr. Karen's and I just want to talk a little bit very quickly about the serial dilution lab. So what I'm showing you here, this is a slide from chapter 6 in the textbook, and notice what it says. A serial dilution and viable plate count for estimating microbial population size. So this image is showing you a serial dilution and viable plate count experiment, very similar to the one that you do in lab. Why do we do this? We want to do it because we want to find out how many microbes, how many cells or colony forming units. So colony forming units are cells, because if you let them incubate, they will develop into colonies on a plate. So you want to know how many cells or colony forming units are in an undiluted sample. And so in lab, you have a tube of some microbe. If you're using the lab kit, the microbe that we're using is yeast. You have a tube of an active culture of yeast, and you want to know how many yeast cells are in 1 milliliter of this tube. In real life, you would be doing this, let's say you work for the EPA and you're trying to measure bacterial counts in a local lake. You can't possibly count all the bacteria in the lake. So you take a representative sample, and even that sample will have too many cells for you to count reasonably. So in the same way, in the lab, 1 milliliter of broth of a liquid culture is going to have millions and billions of cells in it. You cannot possibly count that on your own, but you still want to know a ballpark estimate of what is in that 1 milliliter of undiluted sample. So what do? You dilute your sample several times. Each time it's diluted by 1/10. And then for some of those dilutions, you take a small sample of those and plate them onto agar plates and allow those plates to incubate. Now the idea is that even though you're diluting your samples here, the amount of dilution that you put on the plate is still going to contain some cells. How many cells? Well, you don't know that until you allow those cells to incubate and turn into colonies. So when you're counting the colonies on your plates, really what you're doing is counting how many cells you put on the plate from your diluted sample. So we want to pick a plate that's going to give you an accurate count, and that is where the 30 to 300 colony count comes into play. So in this example, you had an undiluted sample and it was diluted by 10 serially, and then those dilutions, 0.1 milliliters, were placed onto plates and allowed to incubate to let the colonies grow. And you can see that the most undiluted samples still have way too many cells to count, but the more dilute you get, the fewer cells are in the tube, the fewer cells you put on the plate, and so now you have a reasonable number of colonies that you can count. So in this example, which plate do you use? Well, there's only one plate where the colony count falls between 30 and 300. So this is the plate that's going to give you the information that you need. So if you just count the colonies and say, oh, I have 65 cells, that's not accurate. You have 65 cells that were put on this plate that developed into colonies, but you want to know how many cells were in the undiluted sample, specifically 1 milliliter of that undiluted sample. So you have to take into account not only the number of colonies on this plate, but how much you put on the plate and what your dilution was that you put on the plate. So if you're using the lab kit, you were instructed to put 0.125 milliliters on your plates. That's your volume that you need. When you look at your plates and you count your colonies, pick one of those plates that has a colony count between 30 and 300. 30 and 300. Then figure out, okay, well, what dilution is that plate? In this example, this plate with 65 colonies came from the 10 to the minus third dilution. So that's your dilution factor. And then you have your colony count and your volume. So how do you figure what was in this 1 milliliter of undiluted sample? You take your colonies, divide that number by the dilution factor you put on the plate times the volume you put on the plate. And remember, if you're using the lab kit, the volume is 0.125. But in any experiment that you do like this, you have to pay attention to how much you're putting on the plate, because that's the volume that you need. Okay, again, if you're using the lab kit in this class, I explained to you in Lab 8 how to do the calculation, how to do the math. I know sometimes exponents can trick people up. If you are taking this class face-to-face, I can explain how to do that math in the lab. So if you're watching this before we do the lab, just pay attention when I go through that math. All right, thanks a lot.